Today, Summarize Science is looking at how artificial intelligence is learning to communicate through data. Usually, when an AI is asked to create a chart, it might write code that looks correct but results in a messy or unreadable image. The researchers behind this paper noticed that many failures only become obvious once the chart is actually rendered on screen. To solve this, they created a structured workflow that treats making a chart like a careful, multi-step project. This ensures that the final visual is actually useful for a human to look at. Take a look at these examples created by their new system. It can take a raw table of data, like weather readings or medical records, and turn them into clear, professional visualizations. The system doesn't just stop at the image. It also generates a description and a set of questions to test if an AI can understand the chart. For example, it can ask which color represents a specific category or what a trend line suggests about the future. The first step in the process involves carefully screening datasets to make sure they actually contain useful information. It filters out datasets that are just lists of ID numbers or contain confusing, opaque codes. Once a good dataset is found, the system suggests 10 different types of charts that could best display the facts. This diagram shows the complex brain behind the operation. Instead of a one-shot guess, the system selects a dataset, proposes a plot, and then enters a refinement loop. If a chart has overlapping text or confusing colors, an AI checker flags the issue immediately. The system then rewrites the code and tries again until the chart is easy for a human to read. This feedback loop helps eliminate common mistakes like poor scaling or missing legends. Using this method, the team produced a massive collection of 1,500 charts covering 24 different families. They then tested 16 of the world's most powerful AI models to see how well they could read these images. The graphs here show that while models are getting very good at simple tasks, they still have room to grow. For instance, most models have almost perfect scores when it comes to understanding basic chart labels and titles. However, tasks like value extraction and complex reasoning remain significantly more difficult for current AI. Comparing two different points on a radar chart or a 3D scatter plot proved much harder than reading a simple bar graph. This suggests that the real challenge isn't just recognizing a chart, but actually thinking through the data it represents. To recap, the researchers have shown that a check-and-correct approach is vital for high-quality AI visuals. They moved beyond simple code generation by focusing on the actual visual experience of the end user. This work provides a new gold standard for training and testing how AI understands the world's data. In the future, this could lead to smarter digital assistants that can explain complex statistics as easily as a human teacher. It could also make scientific data more accessible to everyone by automatically creating clear, accurate summaries. Thanks for watching Summarize Science, and stay curious about the world of data.